let's learn about yet another way to visualize data called a histogram. A frequency histogram shows the distribution for continuous numerical data. When I say continuous numerical data, I mean data I'm collecting that's a number, like your time to run 100 meters, and it is continuous. You know, you could get 20 seconds, you could get 21 seconds, or maybe 20.2 or 20.7. Numbers between are okay. We group the data into class intervals. So we group it into groups, and then we count how many are into each group. Let's try it with an example here. You can see I only have 8, which is a bit silly. Normally you do statistics on hundreds or thousands, or for AI, millions of data points. But let's just do 8. You can see that there are 8 runners here, and these are their times in seconds to run 100 meters. This person ran 18 seconds. This person ran 100 meters in 15.8 seconds. Let's organize it or group it into class intervals. You can see my numbers go from about 15 to about 23. I could group them in tens, and I could have a group that's from 0 to 20, and another group that is from 20 seconds to 30, and group it that way. But I don't think this would be a very good grouping, because then most of them would fit into one group. Yep. And then the others would fit into a second group, so there would only be 2 groups. That doesn't seem like a good grouping if there are only 2 groups. For class intervals, you will want, somewhere between 4 to 8 groups was normally good, or 4 to 10 even. So maybe we'll organize it in 2-second groups. The first group, let's go from 14 seconds to 16 seconds. So I'll do it in groups of 2 seconds. You might notice that I've got these symbols here. This means 14 is less than or equal to t, which is less than 16. The reason I've done that is because this means that t has to be less than 16 seconds. If it's exactly 16 seconds, we'll put it in the next category. But t has to be at least 14 seconds. If it's exactly 14, we'll pop it in this category. Hopefully this will make sense as we see an example, which is this one that fits right on the edge later on, and we'll see where that goes. Anyway, so we've got the 14 to 16 second category. How many of these fit into 14 to 16 seconds? Just one. This one. So there is one. Frequency means how many, and there is one. The next category then, or the next class interval, the next group, would be 16 to 18, not including 18. Okay, so which ones fit between 16 to 18 seconds? None of them. None of them do. It looks like this one should fit in. But remember, this means t is at least 16, so 16 is okay, but has to be less than 18. If it is 18, it doesn't count. The next group is 18 is less than or equal to t, and t is less than 20. So that one will fit into that category. This one here won't fit. That will have to go into the next one, because if it is exactly this number, then it doesn't match that rule. Oh, there must be another one that I've forgotten. Oh, here it is. Good. The next one will be from 20 to 22 seconds. So that one will fit because it is at least 20, and that one, but not this one. Whoops, I forgot that one. There we go. And the next one is 22 to 24 seconds, which is these two here. Good. Just to check, if I add up the frequency, 1 plus 2 is 3, plus 3 is 6, plus 2 is 8. That's the total count. 1, 2, 3, 4, 5, 6, 7, 8. So that is how you can organize the data into class intervals. We have a hint here for the next question, which is that the modal class is the most common class interval. Each of these is a class interval. Which class interval appeared the most? Well, that would be this one. So the modal class is 20 is less than or equal to t, which is less than 22. What does this mean? Well, it means that runners usually finish between 20 to 22 seconds. Another way of looking at it is that 20 to 22 seconds is the most common class interval. We can use this to create a histogram. Ooh, what happened there? Nothing. I don't know. So let's draw a frequency histogram. You'll notice that this is our table from the last slide. A histogram is very, very similar to a column graph, except it has no gaps. The numbers are between the columns, so the numbers will go here. Oopsie, that's a lie. We'll see how that works. Numbers are between the columns instead of in the middle of each column, and each column represents a range of value. Those are the three differences. We're going to graph, normally the first thing that you're graphing goes on the bottom, usually as a rule of thumb, and the second one goes on the y-axis, on the vertical axis. So we'll put frequency here. I could put frequency and go up in twos, 2, 4, 6, 8, but I'm not going to do that. My largest frequency is 3, so my whole graph would only fit in this little part of the space that I've got. So instead of going in twos, let's try going in ones. 1, 2, 3, 4. Yeah, that will fit with enough room. On this axis, I've got time. Important to put the unit. It's time in seconds. And the time, well, I've got 14, 16, 18, 20, 22. Those are my cutoffs for each class interval. There we go. So 14, 16. Maybe you can start to see what I mean, that the numbers, instead of being in the middle of a column, like let's say I've got a column like this, for a column graph, I'd put the number here representing that column. But for a histogram, I've got a 14 over here and a 16 over here, and we count how many are between 14 to 16. There was one runner between 14 to 16, so they go here. One runner scored a time between 14 and 16 seconds. How many runners scored a time between 16 and 18 seconds? None of them. How many runners scored a time between 18 and 20 seconds? 2 of them. So I can go up to 2. How many runners scored a time between 20 and 22 seconds? 3 runners. And how many runners scored a time between 22 and 24 seconds? 2 runners. If I count the squares, 1, 2, 3, 4, 5, 6, 7, 8, you can still see the 8 runners there. And you can count how many people were in this bracket. 1, 2, 3. 3 students were in this class interval. How many runners were there in total? Well, we've already seen there were 8. We can add up the frequencies or count the number of blocks here because I went up in ones. What percentage of the runners were slower than 20 seconds? There are a few ways to do that. One way is, well, here's the 20-second cutoff right here, right? So I can go, there was 1, 2, 3, 4, 5. Just to make that clearer. 5, 1, 2, 3, 4, 5 runners that scored a time of slower than 20 seconds. Remember that slower than 20 seconds means that your time was bigger than 20 seconds. Or I can go here. Well, 3 plus 2 is 5 students that were slower than 20 seconds. So 5 out of how many in total? Out of 8. I can write that as a fraction, 5 over 8. To get it as a percentage, I need to multiply it by 100, and then I'll put a percentage sign at the end. Do not use the percentage sign on your calculator. Do not use the percentage button on your calculator. It will only confuse you. But if you do 5 divided by 8 times 100, you will get 62.5, and then you can put a percent sign. And I can guarantee you, when I was in school, yes, I was one of those 62.5%. That was running quite a lot slower than 20 seconds. But I gave it my all, you know? I gave it my best. Anyway, I hope you've learned a little bit about histograms and about trying your best on sports day. Bye, everyone.